Good day everyone, my name is John Jericho R. Jose from PIE2K, here to explain to you our lesson for today, fuel system. But first, what is a fuel system? Fuel system means all components involved in transporting, metering, and mixing the fuel from the fuel tank to the combustion chamber, including the fuel tank cap, fuel pump, fuel filters, fuel lines, and fuel injection components. What are the parts of a fuel system? Well, there are fuel injectors, fuel pressure regulator, fuel lines, fuel filter, fuel pump, evap system, and fuel tank. Fuel injector is an electronically controlled valve that is supplied with pressurized fuel by the fuel pump, and when energized atomizes the fuel into a fine mist so that it can burn easily in the vehicle's engine. Types of fuel injector layout: single point in fuel injection, multi-point fuel injection, sequential fuel injection, and direct injection. Single point fuel injection or throttle body injection. A single point injection system features a common fuel injector for all the cylinders in the combustion chamber of the engine. This is the oldest and simplest form of the fuel injection system. In place of the carburetor, the single-point injection uses one or two fuel injector nozzles in the throttle body, which is why it's called throttle body injection, TBI for short as well. The fuel is sprayed in all cylinders at the same time. However, as opposed to the carburetor jet, comes from an injector and can be monitored by an electronic control unit. While it has an edge over the carburetor, it has a slight disadvantage that since it uses a single injector, it disturbs the performance of an engine at high RPMs and causes rough ride quality as the required fuel supply isn't fulfilled. Moreover, a small fraction of fuel gets condensed outside the intake manifold of the cylinders, and this causes fuel wastage. Multi-point fuel injection or port injection. In multi-point fuel injection technology, every cylinder in the combustion chamber of the engine is given an injector at the front of their inlet valves, which is why it's also called port injection. Every injector sprays fuel at the same time and each cylinder gets a more precise volume of fuel with less possibility of fuel condensation outside the intake manifold, while MPFI has the advantages of lower fuel wastage as compared to TBI. Since the fuel is sprayed at the same time in all the cylinders, it doesn't get properly synced with the rotation of all the pistons. This results in the fuel idling in the engine and port for as long as 150 milliseconds. All the same, from the performance point of view, the MPFIs function much better as compared to TBIs. Sequential fuel injection. The sequential fuel injection system eliminates the only disadvantage of MPFI, and it's the most widely used fuel injection system today. In a sequential fuel injection system, the fuel injectors function with respect to the cylinders they are connected to. Every injector injects the fuel only when the intake valve of the cylinder opens. It remains idle for the rest of the steps. The ECU monitors the movement of cylinders and triggers the injectors only when required. The sequential fuel injector is the most effective and efficient of all the fuel injection systems currently available in the automotive industry. Direct injection. In direct fuel injection, the system is focused on placing the injector inside the cylinder to directly inject the fuel, bypassing the intake valve or manifold. While this type of fuel injection system is usually seen in diesel engines, it has a significant space in petrol engines as well, where it's known as GDI. In the previously mentioned system, the fuel is sprayed on the intake and there is always a potential of fuel condensation to some extent. However, in the DI system, all the fuel is directly injected into the cylinder, which produces maximum fuel economy, and this is its greatest advantage. Automakers have also found that GDI engines are relatively more powerful and quite convenient for better CNG fuel efficiency. Parts of a fuel injector. So as you can see here, this is the top part, which is the filter and the electrical connection. This is where the fuel line sits, and this is where the electrical connection is connected. Inside there are solenoids that are wind up, and the solenoid armature is actually a magnet that carries the needle valve. Now, in this next picture, we can see that when the solenoid is off, the valve spring and the needle valve is closed. But when the solenoid gives a pulse, the pressurized fuel passes through it and then sprays the fuel inside the intake manifold. How a fuel injector functions. Fuel pressure for a fuel rail is usually on the order of 35 to 50 psi. Fuel injectors are connected to a rail, but their valves remain closed until the ECU decides to send fuel into the cylinders. Usually the injectors have two pins. One pin is connected to the battery through the ignition relay, and the other pin goes to the ECU. The ECU sends a pulsing ground to the injector, which closes the circuit, providing the injector's solenoid with current. The magnet on top of the plunger is attracted to the solenoid's magnetic field, opening the valve. Since there is a high pressure in the rail opening, the valve sends fuel at a high velocity through the injector spray tip. The duration that the valve is open and consequently the amount of fuel sent into the cylinder depends on the pulse width. When the plunger rises, it opens a valve and the injector sends fuel through the spray tip and into either the intake manifold just upstream of the intake valve or directly into the cylinder. Fuel pressure regulator. A fuel pressure regulator helps maintain the fuel pressure in the electronic fuel injection system. If the system needs more fuel pressure, the fuel pressure regulator allows more fuel to go to the engine. How fuel pressure regulator works. The fuel pressure regulator sees the fuel rail builds up enough pressure to support the vehicle's fuel injection system with the right amount of fuel. So, more on this later, but the basics is that when a fuel pressure regulator is closed, it has no vacuum applied. Now, we'll notice where vacuum is coming from in the next slides, but as you can see, when the regulator is turned off, the return line to the fuel tank is closed, but when vacuum is applied, the return line returns to relieve pressure if need be. Parts of a fuel pressure regulator. This is it: the intake manifold, air chamber, diaphragm, valve, fuel inlet, and this is to return to the fuel tank. Fuel lines are the ones responsible for transporting fuel from the fuel tank to the fuel rail and consist of a feed line and return line. Types of fuel lines: metal lines, rubber hose, braided rubber hose, PTFE lined hose. Metal lines. Most cars come from the factory with metal lines because they hold up better than any soft material. They are usually made from stainless aluminum or coated steel tube. Metal is the best material for fuel lines, however, it can be difficult to fabricate. Rubber hose. Rubber fuel hose is easy to install. It's typically connected using standard barbed fittings and fuel line hose clamps. It must be rated for fuel or be labeled as meeting one of the following SAE grades. SAE J30R7 is carburetor-rated fuel hose and should only be used in limited runs up to 50 psi. SAE J30R9 is fuel injection-rated fuel hose which can handle up to 100 psi. While easy to install, rubber hose has some downside and shouldn't be used to plumb an entire fuel system. It starts degrading as soon as fuel hits it. With the exception J30R9 rated hose, it will leak fuel vapor which can leave your garage or vehicle smelling like raw fuel. It's susceptible to cuts, nicks, and other abrasions. Braided rubber hose. Braided hose is rubber hose with either a braided stainless or braided nylon exterior. It uses AN hose ends to connect with the rest of the fuel system. While more durable than plain rubber hose, it still has similar issue with long-term durability and fuel vapor. So the one you see with the red and blue is the AN hose ends. PTFE lined hose. PTFE lined hose is the best soft hose you can use and generally has a braided stainless or braided nylon exterior. The PTFE liner blocks fuel vapors and slows down degradation process. PTFE braided hose requires special fittings. You cannot use a standard AN fitting with this hose. It also less flexible than standard braided or rubber hose. Fuel filter. A fuel filter is a filter in a fuel line that screens out dirt and rust particles from the fuel and is normally made into cartridges containing a filter paper. They are found in most internal combustion engines. So this is the sample of a gasoline fuel filter. As you can see, this is the fuel cover, supporting plate, internally welded edges. Where's that? Number 3. Oh, there it is. Sealing ring inside of it. Filter medium, this whole yellow thing. Pressure resistant filter housing, the housing of the fuel filter. And the flow of it is inflow the contaminated gasoline from the fuel tank, then into the filtration filtration system, and then letter C is the outward of the clean fuel after it's been filtered. Fuel pump. The fuel pump is the one responsible in providing a constant fuel pressure delivered from the fuel tank going into the fuel injectors. Electronic fuel pumps are the standard for EFI engines because it needs consistent pressure when needed by the ECU, parts of a fuel. So if you have dismantled a starter motor, it's basically the same, only this time this motor has a turbine impeller. And as you can see, the fuel flows right through the main pump. But if you're wondering what if this caught on fire once it gets heated up, well, you need oxygen before fuel fires up even when heated up to 100 degrees Fahrenheit, and that's why fuel pumps are always submerged in gasoline inside the tank to avoid it being having contact with oxygen. Fuel pump assembly. So as you can see, this is a whole assembly. Usually a fuel pump assembly has the fuel gauge float, and as you can see, here's the inside where it's always submerged. The fuel pump, oh sorry, the fuel pump is always submerged in the fuel so that it won't suck in air while it's pumping. And there's the fuel outlet, pump and gauge electrical connection, and tank vent and evap connections. More on this in the next slides. Fuel tank pressure sensor. And there it is. Evap system. The evaporative emissions control system, or evap, is used to prevent gasoline vapors from escaping into the atmosphere from the fuel tank and fuel system at all times. Parts of an evap system: vapor canister. This component, which is also known as charcoal canister, stores fuel vapors from the gas tank. Purge valve, also known as a canister purge solenoid, this PCM controlled valve opens to allow fuel vapors to be drawn from the vapor canister into the engine. Gas cap. The gas cap has a pressure vacuum relief valve that opens in the case of a system malfunction. Fuel tank pressure sensor. The fuel tank pressure sensor, or EVAP pressure sensor, measures the pressure and therefore the vacuum in the fuel tank. Storing fuel vapors. Oh wait, sorry. How EVAP system works. Storing fuel vapors. The vapor canister is the focal point of the EVAP system. When the engine is off, fuel vapor from the gas tank are stored in the canister. The canister contains activated charcoal which traps the vapor until the engine is running and conditions are correct for a vapor purge. Now, next. Normally, the vapor canister is open to the atmosphere to allow fresh air to enter. The canister is only closed when the evap monitor is run. Purging fuel vapors. On modern vehicles, the PCM determines when to initiate the canister purge. When the module deems conditions to be correct, it commands the solenoid to open the purge valve. Opening the purge valve creates a vacuum that pulls fresh air through the vapor canister. The fresh air picks up the fuel vapors and delivers them to the engine to be burned during the normal combustion process. Fuel tank. The fuel tank is a reservoir that holds the fuel supply and helps maintain its temperature at a level below its flash point. The fuel tank also serves as an important means of dissipating heat from the fuel that is returned from the engine. Types of fuel tank. Metal. Steel or aluminum fuel tanks welded from stamped sheets. Although this technology is very good in limiting fuel emissions, it tends to be less competitive and thus less on the market. Although until recent times, automotive fuel tanks were almost exclusively made from sheet metal. Plastic high density polyurethane (HDPE). Fuel tanks are made by blow-molded HDPE, can take complex shapes for instance allowing the tank to be mounted directly over the rear axle, saving space and improving crash safety. Initially, there were concerns over the low fracture toughness of HDPE when compared to steel or aluminum. Concern for safety and long-term ability to function should be considered and monitored. So this is the fuel system diagram. Here you can see the manifold vacuum. This is the pressure regulator. It's connected to the manifold vacuum source. Here, it flows right back to the pump after it passes through the fuel rail, injector, fuel filter, and the evap emission control canister, how it's connected inside the engine. So the evap emission control canister is connected here and here in the fuel tank and in the engine manifold, intake manifold. There you go. And fun fact, how do gas pumps know when to stop? As gasoline enters the tank, air begins to exit it. Gas pump stops when there is no more air flowing through the nozzle, and the change in air pressure causes the nozzle valve to shut down automatically. Thank you for listening.